let's graph some of these things, and then we'll talk about domain and range, and then we'll do just one more example. So in part A, let's graph y equals 2 to the x. Now this, y equals 2 to the x, is the same function we looked at earlier, n of t equals 2 to the t, right? We're just changing the letter that represents the input and the output. But what we didn't look at earlier was what happens if the input is negative, because it didn't make sense to have a negative time. So now this is more generic, and it is okay to plug in negative values for x. So let's make a little table here. X versus y. We know what happens if you plug in 1, 2, or 3, right? So what's 2 to the 1? If you plug in 1 for x, you get 2 to the 1, which is? 2. Just 2. What, at 2 squared, if you plug in 2 for x, you get 4. 2 cubed is 8. We looked at those earlier, right? When we made this table for that bacteria problem, right? We looked at those earlier. But what we didn't look at is what happens if your input, your x value in this case stands for your input, is negative. So, or 0. So let's look at 0. Actually, we did look at 0 earlier, but we didn't look at -1 or say -2. So if you plug in 0 for x right there, what's 2 to the 0 power? 1, right? Remember that? 2 to the 0 power is equal to 1. What's 2 to the -1? If you plug in -1, what do you get for y? What does the negative do? Flips it. So 2 to the -1 would be half, yeah. 2 to the -2, what would that be? 1 over, same as 1 over 2 squared, right? 1/4, yeah. So there you go. There's a good set of x and y values to plot. So I'll start with 0, 1, right there. Let me move this graph up a little bit. This graph paper up. Okay, and then, of course, I need to replot my point. Okay, so 0, 1, 1, 2, 2, 4. 1, 2, 3, 4. And then at -1, I'm up about a half, about right there. And then at -2, I'm up at 1/4, which is 1/2 of 1/2, so right about there. Now, my question to you is this graph, so I'm going to connect the dots in a second, but is it ever going to cross the x-axis? Another way of asking that, will y ever, in this table, is there ever a value you could pick for x and get y equals 0 as an output? Or even y is a negative number as an output? No. None. There doesn't exist an input such that you'll get 0 as an output or a negative number. And think about it. If you raise 2 to a positive number, you get powers of 2, right? Which are positive. If you raise 2 to a negative number, you get fractional powers of 2, don't you? If you raise 2 to the 0 power, you get 1. 0 is never an output of an exponential function, and neither is any kind of negative number. So that means when you connect the dots, you should draw it so that it gets, as it goes to the left, it gets closer to the x-axis. It certainly looks like it's getting lower as it goes to the left, right? But it's never actually going to touch. So when you draw it, connect the dots in a nice, smooth curve. And we know it goes up really quick, right? But when you draw it, make sure it doesn't hit the x-axis. And in fact, the x-axis is actually called an asymptote. So that's, yeah, fancy jargon. That's a fancy name for saying it's a line that the graph gets closer and closer to but doesn't actually touch. At least that's kind of an informal definition, and it's not strictly true with all functions, but in this case it's true. This asymptote is a line that the graph gets closer and closer to but doesn't actually touch. In this case, it's the x-axis, isn't it? But what's the equation of the x-axis? It's y equals 0. It's a horizontal line. And the equation of any horizontal line is y equals whatever its height is, in this case 0. Okay? So just remember, an asymptote is a line the graph never gets to, or I'll just say never hits. Okay. So that's the graph of y equals 2 to the x. Does that make sense to you? So we just plotted points and connected the dots, and then we noticed something new, an asymptote. I don't think we've talked about asymptotes before. Okay, so then what would it look like if we graphed in part B y equals 2 to the negative x? So let's do another chart. In this one, y equals 2 to the negative x. So let's plug in the same values, 0, -1, -2, and just 1 and 2. I won't plug in 3. And what do we get if we plug in a -2 for x? So we get y equals 2 to the opposite of -2. What is that going to be?
4.
Positive 4, right? Because that's the same as the opposite of -2 is 2. That's 2 squared, or 4. So the input of -2 goes to an output of 4. What happens if we plug in -1? So we're plugging it in right here, right? So we plug it in right there. We get the opposite of -1 when we plug it in. What is that going to give us? 2 to the 1, which is, 2. What happens if we plug in 0? What's 2 to the opposite of 0? What would that be? Yeah, it's the same as 2 to the 0, right? The -0 is 0. So 2 to the 0 is 1. But now what happens when we plug in 1? We get the opposite of 1 on top, right? Or -1. And what's 2 to the -1? Whoops. 2 to the -1 is 1/2. And then what's going to happen when we plug in 2? We end up with 2 to the -2, right? Which is 1/4. So we kind of reverse the outputs, don't we? That we had in the first example. Okay, so what does that mean? That means, I'll do this graph in green. That means, we still go through 0, 1, right? But -1 goes up to 2. -1, 2 is on the graph, and -2, 4 is on the graph. And then at +1, we're at -1/2. At +2, we're at -1/4. +2, we're at -1/4. So what does it look like? I'm going to draw a nice smooth curve. It's still not going to go through the x-axis for the same reasons as in part A. What does it look like we did with the graph in red? So that's the graph in green is y equals 2 to the -x. The graph in red is y equals 2 to the x. What does it look like we did here? 2 to the x. Kind of looks like we just flipped it, right? We reflected it maybe across the y-axis. That's exactly what happened, but you don't need to worry about that here. Just plot the points. Again, the x-axis, y equals 0, is an asymptote.